This is the foundation on which we are going to erect our semi-permanent administration building. It consists of a concrete foundation wall with redwood sills and concrete piers supporting a wooden girder. In this film, we will add the floor joists, the subflooring, and the walls of our building. The framing methods and details shown will generally apply to all frame buildings, but may be altered to fit varying conditions. We will erect our building to its specified height of 2 stories. Before we start actual construction, the plumbers install waste and service lines. When this is done, we start the floor joists, which will look like this when in place. This member, running across the ends of the joists, is called a header, and together with the sill proper, forms what is known as a box sill. Since the joists run across our building, we place the layout marks on the headers. To make clear the reasons why we lay them out as we do, we'll leave these actual joists in the picture for the present. Generally, floor joists are spaced 16 inches on centers, meaning that from center to center, or face to face, the joists are 16 inches apart. As most building material comes in even foot lengths, our layout must be accurate. To ensure accuracy, we use a steel tape in laying out. To establish the first joist, we hold the tape on the end of the header and measure off 1 foot 4, or 16 inches. This point falls in the center of a joist. Since we must be able to see any location mark we make when nailing our joist in place, we move back half the thickness of the joist. We're using stock which has been surfaced on 4 sides, so the thickness is 1 5/8 inches. Half the thickness, therefore, is 13/16 of an inch. On this new mark, which as you see represents the side of the joist instead of its center, we square off a line across the face of the header. To make sure that the joist will be properly positioned, we mark an X here. Now to continue without the joist for reference, as of course we have to do in actual practice. Obviously, a joist must go directly on the very end of the building next to the corner, so a line plus an X indicates its position on the end of the header. Because the end wall of the building will sit directly above the end floor joist, good construction practice calls for it to be doubled to carry this extra weight. So a line is drawn here to indicate the filler blocks, which are placed between the 2 end joists, and another X here for the second common joist. Here is how the end will look when we have finished. What we've done so far, then, is to lay out the placement marks for the double end joist and for the first single joist. We drive a nail at this point, hook on the tape, and starting from there, we lay out the rest of them. In doing this, you'll notice that the marks fall in rotation on the 4-inch, 8-inch, and even foot marks of the tape. Where the plans show a partition on the first floor, the joists are doubled in the same manner as at the end of the building. Remember that this does not change the spacing of the floor joists, which fall before and after the partition. The header on the opposite side of the building and the girder are laid out in a similar manner to the first header. Notice that no X's are placed on the girder since the joists are lapped. Due to this lap, the layout on the other side of the building will be offset by the thickness of 1 joist. We're ready to put in the joists themselves, which have been squared on 1 end. The double end joist is first spiked together, filler blocks being used at intervals throughout the length of the joist. They're toe-nailed in position, and 16 penny nails are driven through the header and into the ends of the joists. In the meantime, others of our crew have cut solid bridging to length. A piece of this bridging is now placed on the girder in this manner, with the end of it against the end joist. It is nailed securely to both the girder and to the end joist. The next floor joist with the crown up is now pulled tightly against the other end of this piece of bridging. The joist is toe-nailed to the girder and also face-nailed through into the end of the bridging. The ends of the joists are nailed to the header and sills by others of our crew who move down the building with us. No matter how carefully the bridging has been cut to length, we may find that from time to time we have picked up a little error, due either to slight differences in stop thickness or possible failure to nail bridging and joists together with equal tightness as we've gone along. For this reason, we must carefully check the position of each joist as we come to it, and, if necessary, leave out a piece of bridging and start anew from the layout mark. Bridging to fill such gaps can be cut to the required length by other members of the crew while we go ahead with the operation. The next step is to nail in the intermediate bridging, in our case, halfway between the outside walls and girder. It will look like this. Herringbone bridging, sometimes called cross bridging, is generally used for maximum rigidity. This bridging can be pre-cut to length. It is nailed into place along a snapped chalk line. One piece of bridging goes on each side of the line, in each opening between joists. Notice that nails are started at both ends before each piece is put in place. Notice, too, that the lower ends are not nailed at this time, but will be nailed after the building framework has been completed. Since the joists were put in place with their crown up, sufficient time must elapse for them to settle and lose some of their crown. With joists and bridging in place, we now lay the subfloor. Over this, our finished floor will later be laid. Subfloor boards are laid at a 45-degree angle with the floor joists. Each board thus forms a series of triangles with the joists as it crosses them, which results in strengthening the whole floor frame. Any joints in the subfloor must fall over a floor joist, and ends may be allowed to project temporarily beyond the building line, allowed to run wild, as the builder would say. From time to time, as the subfloor is being laid, a chalk line is snapped along the building line. The wild ends are neatly trimmed off and used to start new courses. Our next step is to nail down the bottom members of the walls and of the partitions of our building. These members are known as sole plates. The sole plate of the outer wall runs in a continuous line around the outside edge of the building, just as the wall itself will run. Sole plates for partitions are located in accordance with our floor plan. Their location is established by measuring, and layout marks are made for them. Lines are snapped between the layout marks, and the plates are nailed to the subfloor and floor joists with 16-penny nails. Walls are to be erected on the wall sole plates. They will look like this after we get them up. The first step is to lay out for the studs in much the same manner as we laid out the headers to receive floor joists. By checking the plans, we find that on this wall we will have a door, the center of which is 24 feet from this corner of the building. We tape off this distance and make a mark on the plate, indicating the center line. The plan view of the first floor, as well as the specifications, shows this door to be a 3068, meaning a door 3 feet no inches wide and 6 feet 8 inches high. To make perfectly clear just how we lay out for this door, we'll use this completed door frame as a guide. In addition to the 3-foot width of the opening, we must allow extra space on each side of it for our door frame, plus additional space so that we may adjust the frame if necessary to set it in absolutely plumb. This allowance is known as the framing allowance. This framing allowance will always be the combined thickness of these two members, called side jambs, plus 1/2 inch on each side. In the case of this particular door, this adds up to a framing allowance of 3 1/4 inches. In laying out the sole plate, we measure off on each side of the center line a distance equal to half the width of the door plus half of our framing allowance. For this job, it is 19 5/8 inches on each side. The line we place on each side at this distance indicates the trimmer, and we mark its position by placing a T on the outside of the line. The trimmers, one on each side, are the vertical members framing our rough opening. Since they do not extend clear up to the top of the wall, a common stud is to be placed next to each one. This is known as a door stud, and the trimmer will be nailed to it. In laying out the sole plate, the location of this stud is marked by lines. And indicated by an X right next to the T. What we've done then is to lay out on the sole plate the width of the door opening and the location of trimmers and of the door studs. Taking away the finished door frame which we have used as reference, we now have marks on the sole plate indicating the center line of the door and the position of the trimmers and door studs, one each on both sides. Since in actual practice the rest of the studs will be already laid out, we make sure that there's no misunderstanding about what this opening represents and mark it clearly. The stud marks falling in the door opening are changed to C, indicating short cripple studs to be cut in above the door frame. In the end wall, we next lay out a rough window opening in practically the same manner as we used for the door. The width of the window plus the framing allowance is the total distance between trimmers. However, the framing allowance will depend on what type of sash balance is used. Like door openings, window openings also are clearly indicated on the sole plate. At corners of the building, we'll have corner posts, like this one. It is made up of these three common studs, plus three filler blocks. One block is at the top of the post, another at the middle, and the third at the bottom. We lay out for the corner post on the end of the sole plate. To do it, we take a piece of scrap stock, place it on the plate flush with the end, and line off for the end stud. We must next leave a space to indicate the filler blocks and line off for the other stud on this wall. The third stud to make up the corner post is now laid out. You'll notice that it will be part of the end wall, not the side wall we've been concerned with so far. We then continue to lay out the rest of the studs and openings for the building. After layout is completed, the top plates are placed on the floor alongside the sole plates. Top plates are the members which the studs will butt into at the top of the wall, the way they butt into sole plates at the bottom. Lines are carried across so that each top plate becomes an exact duplicate of its corresponding sole plate. When it is necessary to break the top plate, because of material not being long enough, the break is made in the center of a stud, and if possible, away from door and window openings. With all plates marked, the studs, which have been cut to length, are laid down on the floor and positioned, ready for nailing. We now make up the door opening. We begin by nailing the trimmers to the door studs, using 16-penny nails driven slightly on a slant to increase the bond between the two members. We next install the door header, which is secured on edge at the top of the opening, as you see here. It is laminated of two members, with pieces of lath between them, to build them up to the thickness required to make the outside faces of the header flush with the edges of the door studs. They are now nailed into place. First toe-nailed with 8 pennies to force them down against the trimmers and against the door studs, then end-nailed with 16s. Nails are driven through the top plate and into the door studs. All hands now raise the wall into position, taking care that it goes up evenly to avoid springing the joints. To hold it temporarily in place, braces are nailed on where necessary. At the end of the building, we will have a single window, which will look like this when completed. These members, called bottom cripples, are placed onto the window opening. Additional cripples are nailed to the window studs to give us full bearing. The rough sill is then nailed on. This is of single construction and may safely be placed flat. Next come the window trimmers, nailed to the window studs. Then the window header. This one is double with lath filler between, just as the door header was, and is placed on edge in the same manner. And finally, the top window cripples. To see where these members go in relation to each other, we have our bottom cripples, rough sill, trimmers, header, and top cripples. We now nail the top plate across the top ends of the studs to complete assembly of this particular wall section. Studs are held flush with the edges of the top plate, and 16-penny nails are driven through the top plate and into the ends of all studs and cripples. This end wall is now raised into position. At this point, the corners are plumbed, using a straight edge and carpenter's or plumb level. Again, as we noticed a while back, 2 members of the corner post have been raised with the side wall, and the other member has been raised with the end wall. Nails are driven in to lock the corner. The wall is then set to line and braced into position. The succeeding walls and partitions are raised, and the rough frame begins to look something like a building instead of a pile of lumber. The top plate is now doubled. Notice the resulting kind of interlock we get at the partitions and at the corners of the building. With all walls and partitions raised, we're ready to put in the fire blocks and wind bracing, which will look like this when we have finished. In buildings having a distance between top and bottom plates of over 7 feet, most building codes call for fire blocks to be placed in the wall. They are known as fire blocks because they eliminate the possibility that the space between the studs will act as a chimney or flue in case of fire. We place these blocks 4 feet above the floor. To lay out for them, we measure up 4 feet at each end of the wall and snap a chalk line along which the edge of the fire blocks will be placed. Blocks previously cut to length are then nailed into place between the wall studs. Care must be taken that a slight variation in the length does not bow out the center of any of the studs and thus force them out of line. To guard against this possibility, it's good construction practice to leave these pieces out. You can later cut pieces to fit these gaps and install them after the rest of the fire blocks are in. We next install the wind bracing. We drop back on the top plate to the first stud from the corner and snap a chalk line diagonally down to the bottom plate at an angle of approximately 45 degrees. In no case will the angle be greater than 60 degrees or less than 40 to provide maximum bracing against possible wind loads. Notice that one fire block has been left out. It will be put in after the wind bracing is completed. A piece of scrap material is placed on the line and marked for sawing into individual sections of permanent bracing. To guide in sawing, these lines are then squared across the face of the piece. To help saw accurately, it is best to use a shelf like this, nailed to the inside of the stud wall at a height which enables your saw to best follow the cut line. Accuracy is important when cutting these pieces because the amount of strength given to walls by wind bracing depends on the tightness of fit of each section. You'll notice that this particular member has a combination cut on one end. This is necessary in the case of all top and bottom members for diagonal wind bracing, since the combination cut will butt against the plate and stud. Intermediate sections, of course, have only plain diagonal cuts. 8-penny nails are started in both ends of the members, and they are now nailed into place. When the complete brace is in, short pieces of stock are nailed to the plate at each end of the brace. These are known as kicker blocks. They keep the brace from pushing the stud out of position should a heavy strain be thrown on the side of the building. In wall sections not long enough for full diagonal wind braces, knee braces such as these are installed. The pattern formed by wind bracing varies. It may be in the form of diagonal lines, as we have it, or in the form of a V or an X. Regardless of its pattern, the purpose remains the same: to brace the structure against wind loads. So far, we have put up the exterior walls and partitions for the first floor. Now, we lay out the top plate for the second floor joists. To do this, we simply square up from each 16-inch center stud across the top plate and mark an X to indicate the position of each joist. These second floor joists are installed in the same manner as the first floor joists. Notice the men in the foreground. They're working ahead of the regular joist crew, nailing in joists where they're necessary to maintain correct width throughout the building. The joist flaps for the second floor occur on a bearing partition instead of on a girder, as they did for the lower floor. Solid and herringbone bridging is placed between the joists in the same manner as we did for the first floor. Joists are doubled wherever there is to be a partition on the second floor. At this point, the rough opening for the stairway is framed. This is known as a stairwell hole. It is framed in with carrying joists, trimmer, and headers in accordance with our plans and specifications. The subfloor is laid at a 45-degree angle with the joists and the wild ends trimmed off. Sole plates for the second floor walls are nailed down and laid out just as they were on the first floor. And again in the same manner as for the first story, the upper walls are nailed together and raised into position. The layout for ceiling joists is the same as for floor joists, but if possible, they are positioned so that a space is left for the rafters directly above the studs. This is so that the rafters, which carry the load of the roof, will have full bearing. Notice, too, that the ceiling joists are trimmed off at an angle so that they will not later project out beyond the roof line. The framing of our building is now complete except for rafters. Notice that what we have done is actually construct two platforms, one on top of the other. This type of framing is known as Western framing or platform framing. The main advantage of Western framing is the speed with which buildings of this type can be constructed. To summarize what we've done, we started with this foundation unit, laid out for the floor joists and put them in complete with bridging, then put on the first story subfloor, walls with door and window openings, and second floor joists, and finally erected a similar second floor on top of the first. When we put on the rafters, our building frame will be complete.